Good afternoon, everyone. My name is Dr. K. Nishantha Rao. I'm working as Associate Professor in Department of ECE in MLR Institute of Technology. So, in this video, we're discussing about this antennas and wave propagation. So, in this video, we mainly focusing about the introduction of antenna basics. So, while we consider about the designing of any kind of antenna structure, first we need to discussing about this what is frequency band of electromagnetic wave spectrum. So, what is meant by this electromagnetic wave spectrum? So we know that we design any kind of signal is nothing but is a combination of electric field value as well as is a combination of magnetic field value. So based upon these two field, one is electric field and one is magnetic field value, we design the signal values only. So once these signal is able to transmit the information in the air medium region. So here with the help of this frequency regions only, we design our signal values only. That signal which contains the information. So based upon this respective frequency band, we design the respective signal of that information only. So this information is entering into the free space medium through any kind of antennas. That information is transmitting from one station to another station, which means source to destination. So as we know, we discussing about this frequency spectrum. First, we understanding about this what is the RF band and what is the microwave band. What is RF band? RF band is nothing but it is a radio frequency spectrum band. So in the radio frequency spectrum band, we have n number of bands are there, n number of designations are there. Based upon the range of frequencies, we assign into n number of ranges, starting from this low frequency to till extremely high frequency values only, which is from 3 Hz to which is from 300 GHz values only. So based upon these frequency ranges, we design a respective signal values only. So this signal able to transmit the information. So this signal carries the information. So that information in the form of this electromagnetic wave, which means electric wave and magnetic wave. So as we understand about these kind of frequencies, so every band of frequencies we are using separate kind of communication is there. For example, when you using this extremely low frequency to till low frequency, these are the low frequency band. Generally in the AM communication or normal broadcasting communication, we are able to using this frequency spectrum band. But after while coming to this medium frequency and high frequency, this is used for FM band communication, which means FM broadcasting communication. But after this one, when we entering into this band designation, which is very high frequency, ultra high frequency, super high frequency and extremely high frequency. With help of these frequency ranges, this is a very huge amount of frequency range structure is there, which means 30 MHz to 300 MHz. Similarly, 3 GHz, which means 1 MHz is equal to 10 to the power of 6 Hz. And similarly, 1 GHz is equal to 10 to the power of 9 Hz. So while we are using this much amount of frequency value, so this is a very huge amount of frequency value. So this frequency band we segregate into the micro frequency band. So these bands, which means L band, S band, C band, X, KU, K, KA, V and W, sub-millimeter and millimeter range frequencies, these we calling as a microwave frequency range values only. So these frequency band, generally in these frequency bands, we are using in this satellite communications, right, and missiles communication, radar communication, all these ranges we are using this much amount of frequency values only. So as we understanding about this radio frequency spectrum bands, which means electromagnetic wave spectrum bands, based upon this frequency bands only, we are able to designing the respective antennas. While we discussing about the history of development of antennas, so while in the history of development antennas, the early 1864 we developed the electric field value and magnetic field values only. The Professor Maxwell, he designed the equations of electric field value as well as the magnetic field value. He found the relationship between the electric field and magnetic field values only. Then based upon this field values only, we generate the respective signal values only. And these signal were able to transmit in the free space communication, free space medium values only. So after this discussion of this one, in the World War time, we are using this UHF range values only. We are able to implementing the wire antennas values only. So as we know, any piece of rod, any kind of conductor material which acting as a a antenna. So in the World War II, on the duration, we implemented this wide range antennas only. We calling as a wide antennas only. So these we coming under the range of below UHF range values only, which means high frequency values, and based upon this medium frequency values, on the time we are using only this range values only. But once we entering into World War II, on the situation of time, we are required for this radar communication, which means radio detection and ranging communication. So for this application, this amount of frequency is not suitable for us. So on the situation we are entering, and we are able to using this the microwave frequency spectrum band values only, which is in the form of this gigahertz range values only. So on the time we implemented this kind of frequency values only, we calling as a microwave antennas. So in the radar communications, we are using this the microwave antennas. And after this one, we are able to implement this all the broadband communication or the long distance communication or mobile communications. We implemented the microwave antennas values only. So once coming to this introduction, what is about this antenna? What is mean by antennas communication? Actually, what is the definition of antennas? So in the antennas, we having as n number of definitions are there. So when we discussing about this antenna, as we discussed earlier, antenna is nothing but a piece of connecting material. So any kind of connecting material, either should be a copper wire or any kind of connecting material, it acting as the antennas, which means it transmits the signal value as well as it receiving the signal value. So while we conducting with any kind of connecting material, so it should be transmitting the information as well as receiving the information. That should be in the form of this wire or in the form of rod or any other shape values only. As we discussed in the previous slide, there we discussing about this wire antennas. So any kind of copper wire, any kind of dipole mechanism, so that acting as a transmission kind of signal values only. It transmits the electromagnetic wave values only, or else it receiving the electromagnetic wave values only. Either transmit the values or else either receiving the values only. And similarly, while discussing about this one, and antenna is also acting as a source or a radiator. So what is meant by this source or radiator? So when you go for this any long distance communication, when you go for this a huge amount of frequency, we are using that one. So antenna is able to producing the high range of frequency values only. So there our requirement is source acting as a frequency acting as a source supply values only. So there also antenna is also working as a source, or which also acting as a radiator of my electromagnetic waves or input of my electromagnetic waves. And as we know, a sensor is also acting as a electromagnetic waves, which means it's sensing the some values only, whether it should be temperature sensor values or in infrared sensor values, it's sensing the some atmospheric values only. That is also acting as an antenna. And antenna is also acting as a transducer. What is transducer? In the which means a single antenna can able to transmit the signal as well as can able to receiving the signal. So in the earlier World War II time, we having as a three different antennas are there. One is especially for only for transmission section, especially for receiving section, but now we implemented this transducer section. The especially for transmission section, it just transmits the signal values only, it won't receiving the signal values. At the same time, other receiving section values only, it only receive the signal values only, it won't transmit the signal values. But while in the transducer section, it can able to transmit the signal as well as it can able to receiving the signal. For example, when we use this TV remote antennas or any kind of remote sections, we just transmit the information values only. We can't able to receiving the information to our remote controller. We just transmit the frequency values, transmit the information values only. Same way in the TV communication. In the TV communication, we are able to receiving the signal values only. We are not able to transmit the signal values. But while go for this mobile communication, in the mobile communication, we are able to transmit the signal, we are able to receiving the signal. That is the reason antenna is also acting as a transducer. And similarly, the next one, we also acting as a impedance matching device. Why? In the sense, what are the information we transmitted and what the information we received. There must be, we are in sync with the transmit signal as well as in the receiving signal. Then only the impedance is matching. That we calling as a proper impedance matching. So antenna is also acting as a impedance matching device. And the last one, antenna is also a couple between generator, a transmission line and a space or vice versa. So already we discussed about this one. Antenna is also acting as a source or radiator. Similarly, it also acting as a coupler between the generator for a transmission line. So when you see this transmission line, so when you see this one, this is my source section antennas and this is my destination section antenna, which means my transmit signal values only. So how the information is transmitted? Once we are getting this source supply value, so here VG acting as my source voltage values only. So in the source voltage, we having as respect to impedance of there. So based upon this transmission line, so in the transmission line, we having as two things are there. One is load resistance, and the one is radiator resistance, and similarly the respective reactance of values only. So once we are able to designing about this transmission line, so based upon the standing wave mechanism, so we are able to producing the electromagnetic wave. So when you see this one, especially this circuit is mainly focusing about this Thevenin's equivalent circuit of diagram values only, which means we conversion about this electrical current values only. What are the my source supplies producing? Based upon the standing wave values, we are able to producing the frequency values only, which means it converting the voltage values, it converting the electrical current into electromagnetic wave values only. So in the receiving section, in this antenna section, it converts the electromagnetic wave. In the source section, we having as electric current, but in the antenna section, it convert the electrical current into electromagnetic wave values only. So between these one, we are using a transmission mechanism values only. So in the transmission lines, we are using the passive element values only. So what is the passive element? Resistance, inductor, capacitance and conductance. These are acting as a passive element values only. So in the standing wave section, in the designing of my transmission line, we are using these passive element values only. And after we designing about this transmission line, antenna is converting the current into electromagnetic wave values only. So when you see this one, in the antenna's electric field lines. So while we discussing about this field line values, we having as a positive line is there, we having as a negative lines are there. So based upon the signal propagation values, so how the antenna is propagating, how the electric fields are propagating. When you see this one, these are propagating this direction as well as in the downward direction. So basically we are able to produce in the antenna signal momentum in the respective wire direction only. But same way, when we analyzing the free space communication, this should be in the form of this electric field lines, but this should be in the form of this free space communication. In the free space communication, some kind of tilt should be happens. So the wave should be forming like this only. So here the electromagnetic waves are producing this one. When the distance increases, the electromagnetic spectrum value should be changes values only. So this we calling as a source transmission of antenna with detailed attachment of how the electromagnetic waves are propagated. Either should be in electric field line values or else in the free space communication values. And next one, we discussing about this, what is the transmitting and receiving antennas. So as we discussing in the previous slides, we have three types of antennas are there. One is transmit section antenna, second one is receiving section antenna, and third one is transducer antenna, which means antenna capability to work under the transmit section as well as in the receive section, we calling as a transducer antenna. But in this slide, we focusing about this transmitting section and we focusing about this receiving section antennas. What is transmit section? So here when you see in the transmit section, we having as a generator block is there, respective transmission line is there, and same time the signal propagation to the medium is there, which means this antenna, what are the amount of frequency we are giving, what amount of supply we are giving, that supply can converting into the electromagnetic wave values only with the help of my transmission line. So what is my transmission values only, how the amount of electrons are flowing. So here the conversion of electrical current into electromagnetic wave values only. So here we are using this the propagation constant value because signal is propagating. So as we discussing about this, here we discussing about the transmission line based upon my passive element value. What is the passive element value? R and right. So which means resistor, inductor, capacitance and conductor values only. So here gamma is acting as a propagation constant. So how much amount of wave is propagating into the free space dimension values only, the free space region values only. Apparently that should be the air medium values only. So what is my propagation constant is there. So this propagation constant value is must be depending upon my primary constant value, which is R, L, C and G values. So what are the amount of source supply is producing? Based upon this transmission line, it converting the signals into electrical current signals into the respective electromagnetic wave values only, and these waves are entering into the air medium values only. So here we are using this gamma value. What is gamma? Gamma is apparently acting as a alpha plus j beta, where gamma is equal to propagation constant and alpha we calling as a attenuation constant and beta we calling as a phase constant. So this signal is entering into air medium value. So then we can able to receive through my receiver section antennas. In the receiver section antennas also, right? So when you see this one, the direction of propagation should be, so the direction of propagation should be entering into the free space medium values only. But in the receiver section, these are able to receive the signal from the free space region values only. So here also the same components we are using, that is the receiving section antennas component, respective transmission component and the receiver block. So in the receiver block, what are the amount of frequency we are receiving, which is electromagnetic wave, which is converting into the electrical current values only. So while discussing about antennas, which is conversion of electrical current into electromagnetic waves into the transmission section, but same way in the receiving section, it conversion of electromagnetic wave into electrical current. It should be a vice versa. Based upon this one, we are able to transmit signal, we are able to receiving the signal values only. And while conclude the previous slide, the summary of the thing. So in this previous section, we discussing about like basics of antennas and what are the respective frequency spectrum of antennas and what is the history and development of antennas, and we just focusing about this, the definition and introduction about this my antenna values only. So in this section, we mainly focusing about this, what is the importance of frequency spectrum value and what is the history and development of antenna values, which means where we need to start the antennas, like how are able to growth of history of antennas section of my antenna propagation. And third one, we discussing about this definition as well as we focusing about this designing spectrum of my transmission line. And while the next session, we discussing about this, what is the functions of antennas and what are the basic elements are there. So these are the points we discuss in the next session. Thank you.